We've talked about the different types of energy transfer that can do things to an object, and those things that I just said were you can raise the temperature or you can change the phase. And so those are the different Qs that I mentioned in the last one of these. And so Q, and we're talking about changing the temperature, since Q is representative of the heat transfer, the transfer of energy that is the heat, then that's equal to the change in temperature, how much it actually does change, times the specific heat of the material, times the mass of that material, the amount of stuff you have. Okay? If you're just talking about changing the phase and not talking about changing the temperature, you can't use this equation because delta T is 0. So instead, you use Q is equal to plus or minus, depending on if it's absorbing energy or losing energy, the mass times capital L, which is either the latent heat of fusion or the latent heat of vaporization, depending on if you're going from a solid to a liquid or a liquid to a gas. And then you can have the latent heat of sublimation when you go from a solid directly to a gas, okay, or vice versa. So if you have a multi-step process, like say you wanted to take steam and condense it down into ice at some certain temperature below the freezing point of the water. Okay. So let's say we wanted to do that. So let's say we wanted to take steam and turn it into ice at some temperature below 0 degrees C. Okay. We have to think about every bit of energy that we have to give, well, that we have to take away from the steam in this situation in order to make this happen. Because in order for the steam to become ice in that less energetic state as a solid, then we have to actually take away energy. So we had to put this in a very cold environment in order for that to happen. Okay, so, and you could figure out exactly how cold it has to be for this to work. But let's first of all just think about the energy the steam has to lose in the different steps. So the energy we have to take away from the steam. So the first one would be that we have to get the steam to the temperature where it can actually turn into water. Okay, so that would be the first thing. So lower So we have to lower that temperature of the steam from above 100 degrees Celsius to 100 degrees Celsius. Okay, we have to get to that temperature first, because then once you're at that temperature, then the phase can change. Otherwise, you can't change the phase. And you can't go past 100 degrees in this situation, since we're not changing the pressure and things like that, without getting to 100 degrees first. So, anyway, so we have to lower the temperature of the steam to that condensing temperature. So that means that we have a Q for this first step that's going to be equal to the mass of the steam times the specific heat for the steam times the delta T to take the steam from whatever temperature it's at down to 100 degrees C. This specific heat of steam here is not going to be the same specific heat for water because it's in a different phase. It's going to have a different specific heat. Okay, so that's the first one. The second one would then be, we now have the steam at the right temperature to change into a liquid, but we have to actually make it turn into a liquid. So we have to take away the amount of energy that you would need in order to actually have it condense into that liquid. So we now have to change the phase. So we have Q2, here since we're labeling these, is equal to minus m times the latent heat of vaporization. Minus, because of the fact that we're taking energy away from it. Okay, if I were giving energy to it to change it from the liquid into a gas, then that'd be positive. And the latent heat of vaporization and latent heat of condensation are the same. You just call latent heat of vaporization, and so that's what's going to be there. And this m is going to be the mass of the steam. Okay. So then, we have that situation. Now we want to actually take that newly formed water and bring it down to the temperature where it can then condense into a solid. Okay, where they can then fuse into a solid. So we have to lower the temperature to the freezing point. So that would end up being another mc delta T, so Q3 is equal to the mass of our water now, times the specific heat for water, times the delta T for our water. So again, this C down here is not going to be the same specific heat as this C up here, because it's a different phase for that H2O. Okay, even though we're just talking about H2O and all of this, okay, it's a different phase, and so it's going to have a different specific heat. The specific heat, remember, is the amount of energy, well, it's per mass per temperature that you have to give to something in order to actually make it do what you want it to do, whether that be changing temperature. Well, in this case, it is changing the temperature, okay, because it's not involved with the changing phase part. That's why we have the L. Anyway, so it's going to be different because it's a different phase. So then once we've lowered the temperature to the freezing point, we have to actually freeze it. So then we have to change the phase again. So now we have a new Q that will be a negative mL. So we have minus mass of the water times the latent heat of fusion. Okay, and this mass of the water is going to be equal to the mass of the steam because we're taking all of it and we're condensing it down into the water. So then once we've converted all of the water into ice, then we still want to get down to that some temperature below the freezing point. So we would have to then take the fifth step here to lower the temperature to what we want it to be. So Q5 will end up being the mass of our newly formed ice times the C for ice, which is going to be different from the C for water and the C for steam, times whatever final temperature difference we want to get to. Okay, so the amount of energy you'd have to take away from the steam would be the addition of all of these. Okay, this will be negative. This is negative. That's negative. That's negative, and that's negative. The addition to all of that is the negative amount of energy you would have to take away. Okay. So this is one way. You can think about this going the opposite way. Maybe you're only thinking about changing it from ice into water. Either way, you have to think about all the different stages that this material has to go through to get from the initial point to the final point.